Hey everyone, welcome into Unit 6, Day 6 notes. Today we're going to focus on solving absolute value inequalities and graphing those absolute value inequalities. Students will be able to solve absolute value inequalities and represent the solution via graph and interval notation with 80% accuracy. Okay, so let's jump into it. So a few reminders before we get started with the new content. So reminder number 1, when solving absolute value inequalities, you will need to use the acronym LAGO, L-A-G-O. So we talked about that yesterday in Day 5 notes. So we're going to use LAGO to determine if the inequality is an AND or if it's an OR problem. We use LAGO only, can't stress that enough, only after the absolute value has been isolated. We really focused on that in our notes yesterday, isolating the absolute value, and then we look to LAGO to see if it's an AND or if it's an OR problem. Reminder number 2, after splitting into two inequalities, the second one must be negative and have a flipped sign. After solving, we are going to graph and write in interval notation, which we have graphed and in OR problems before. This time, though, we just have to make sure that we have the absolute value isolated before we do so. And it's going to be an AND or it's going to be an OR problem. Reminder number 3, again, referring back to when we have graphed these before. So if it's a less than or greater than symbol, we're going to use an open circle. And then the bracket type is going to be just a regular parenthesis. If we have less than or equal to or greater than or equal to, it is a closed dot, right? We shade the whole thing in. And then the bracket type is a bracket. And then the final reminder for LAGO, if it's less than, then it's an AND problem. If it's greater than, then it's an OR problem. When we graph AND problems, remember we are going to shade between. So something like this. And if it's an OR problem, we are going to shade outside. So it would be something like that. Okay, so those are all of our reminders. So now let's go ahead and get into the practice, the examples. So first, ask yourself the question, is the absolute value isolated? And in this case, that is a yes. It's isolated, so we can go and look at LAGO. And it is a greater than symbol, so it's going to be an OR problem. Once we are ready with that information, we can go ahead and split. We drop the absolute value bars. We get x is greater than 9, or we get x, remember, flip sign is going to be less than, and then we make the 9 negative. X is by itself, so we are done and ready to graph. So we go ahead and we place, make sure negative 9 is on the left and 9 is on the right, because negative 9 would be to the left of 9 on the number line. It's a smaller value. And we put open circles for both of them. And then it's an OR problem, so we are automatically shading to the outside. That is our shortcut. That's our trick. And then interval notation. Well, we have the arrow on the left, which indicates negative infinity. Infinity always gets a parenthesis. And then we come to the point where we're at negative 9. and it's an open circle, so we give it a parenthesis. Remember, we put our U for an OR problem. And then we come to 9 with an open circle, so we get a parenthesis. And then an arrow to the right is positive infinity. And there we have it. Okay, let's go ahead and take a look at the next example. So is the absolute value isolated? In this case, it is not. So we must add 10 to both sides. And then we get the absolute value of x is less than or equal to 15. Now it is by itself, so we can use logo. It's a less than symbol, so it's going to be an and problem. So now we can split x is less than or equal to 15, and x, remember, sign flip, is greater than or equal to negative 15. And that is it, right? So now we're ready to graph. Again, remember the negative is on the left when we have a negative and a positive. This time it's going to be a closed circle or a closed dot. And it's an and problem, so we automatically shade to the middle. Interval notation. We have no arrows. We have negative 15, though, is the first thing we hit on the left, and it's with a closed dot, so we use a bracket. And then we go to 15, and it's, again, a closed circle, so we use a bracket. All right, let's go ahead and jump to some more examples on the next page. Okay, we're going to do 3 of these together. So number 1, the absolute value is not isolated, so we need to divide by 5 on both sides. This gives us the absolute value of 2x is greater than 4. It is now isolated, so we can look to logo. And it's greater than, so it's an OR problem. So we can split 2x greater than 4, or 2x, remember, sign flip, is less than negative 4. We divide by 2. We get x is greater than 2, or x is less than negative 2. Negative 2 on the left, 2 on the right, open circle, and it's an OR problem, so we're automatically shading to the outside. We have an arrow to the left, which remember is negative infinity. Infinity always gets a parenthesis. Then we come to negative 2 as we move to the right. And again, it's an open circle. Do not forget your U. And then we have 2 with an open circle, so it's another parenthesis. And then an arrow to the right is positive infinity. Okay. Very good. Let's take a look at number 3. I'm going to move this over to give myself a little bit more room to show my work. So bear with me for another second. Okay. So we want to get rid of that 5 in the denominator. So we need to multiply by 5. We are left with 2 times the absolute value of x plus 2 is less than or equal to 30. Now we divide by 2. Absolute value of x plus 2 is less than or equal to 15. Now the absolute value is isolated, so we check logo. It's a less than problem, which means and. So now we can split x plus 2 is less than or equal to 15, and x plus 2, remember, sign flip, is greater than or equal to, and make it negative 15. We solve, we subtract 2 from both sides. We get x is less than or equal to 13. And we subtract 2, x is greater than or equal to negative 15 over 2. Or sorry, we're subtracting. Negative 15 minus 2 is negative 17. Ugh. Okay, now we're ready to graph. Negative 17 goes on the left, 13 goes on the right. They are closed circles. And it's an and problem, so we're shading to the middle. Interval notation, we're at negative 17, and it's a closed circle, so we give it a bracket. Then we go 13, it's a closed circle, so we also give it a bracket. Okay, let's jump to number 6. It'll be the last one we do together, and then we'll give you all a chance to work on some on your own. Okay, so the absolute value is not isolated. We need to subtract 8 from both sides. We're left with negative 2 times the absolute value of negative x minus 6 is greater than negative 20. Now we're going to divide by negative 2. When we divide by a negative and we have inequalities, remember that we need to flip the sign. So let's jot that down. Divide by a negative, we flip the sign. And then we get a positive 10. Okay, now we can logo. It's a less than symbol. And if you forget to flip the sign, you would have an or problem going on, right? So we need to remember to flip that sign. So we get an and problem. Now we can split. We have negative x minus 6 is less than 10. And negative x minus 6 is sign flip greater than, and then it's negative 10. All right, let's go ahead and solve. We add 6 to both sides, left with negative x is less than 16. And now we have another sign flip because we're dividing by a negative 1. So we get x is greater than negative 16. And then over here, we go through the same process. Negative x is greater than negative 4. Divide by a negative 1. So we have another sign flip. X is less than 4. And it's an and problem. So again, jot down your note here. Divide by negative. We have to flip the sign here, here. All right, now it's time to graph. So we have negative 16 and 4. They are both open circles. It's an and problem, so we're automatically shading to the middle. Our interval notation is a parenthesis because it's an open circle, and a 4 with an open circle. Or sorry, with a parenthesis because it's an open circle. All right, great job. Go ahead, take a few minutes to go back and try the other 3 problems on your own. See you back in a few. All right, welcome back. Let's go ahead and check out the answer to number 2. So the final answer you should get is x is less than negative 3 and x is greater than negative 4. Did you remember to flip your sign? Ask yourself that question and check your work, right? When you go from the positive inequality to the negative inequality, did you remember to flip your sign and make that a greater than symbol? And then it's an and problem, so we shade to the middle. We get parentheses, no brackets, because they are open circles. All right, let's go ahead and take a look at number 4. Number 4, we have some sign flipping going on because when we divide by negative right here, we divide by -7, we flip the sign, it becomes a less than symbol. So then it turns into an and problem. And then we have to flip the sign again over here when we are going to the negative inequality and then solving. It is an and problem with closed circles. So we shade to the middle. -15 is to the left of -7. So make sure your order is correct there. And then we give them brackets because they are closed circles. All right, number 5. Again, we have some sign flipping going on right here because we're dividing by a -1. Flip the sign to a greater than symbol, and then again, we flip the sign again when we make the inequality set to a -26. It's an or problem because it was greater than. Or problems, we automatically shade to the outside. And don't forget when we do interval notation, don't forget your U in between. Okay, that is it. Thank you all for stopping by. I hope you have a great rest of your day. Peace out.